This is the Math 3 Unit 11 review worksheet covering sections 1 through 4. 1 through 16, evaluate the following logarithms if needed. Write an equivalent exponential equation. Do these without using your calculator. Okay, so number 1, log base 6 of 30. What power equals 36? And we know that 6 squared is 36, so x is 2. A log is always equal to an exponent. Number 2, we got log base 2 equals 16. This is asking the question 2 to what power is 16? And if you're not quite sure, you think about it a little bit, you end up with 2 to the second is 4, 2 to the third is 8, 2 to the fourth is 16, and so our exponent is 4. Number 3, we get log base 2 equals 0.25. This is asking 2 to what power equals 0.25. If it's helpful to change this to a fraction, the 0.25 is 25 over 100, because the way we read that is 25 1/100ths, and that reduces to 1/4. So now we're at 2 to what power is 1/4. Well, 4 is 2 to the second power, and 1 over 2 to the second power is 2 to the negative second power. So notice the bases are the same. We have base 2 to start with, we have base 2 to end with, and so therefore the exponents must be the same, and we can say the exponent is -2. Number 4, we got log base 5 of 1 over 125. This is asking the question 5 to what power is 1 over 125. 125 is 5 to the third power, and 1 over 5 to the third power is 5 to the negative third power. Bases are the same, so exponents must be the same, and we get x is -3. Number 5 is log base 3 of 1 over 27. This is asking the question 3 to what power is 1 over 27. 27 is 3 to the third power, which is 1 over 3 to the third power is 3 to the negative third power, so our exponent is -3. 6, log base 7 of 49 root 7 is asking the question 7 to what power is 49 root 7. Well, 49 is 7 squared, so 7 to what power is 7 squared times, and the square root of 7 is 7 to the 1/2 power. And when we multiply things with exponents that have the same base, we actually keep the same base and add the exponents. So x is going to be 2 plus 1/2. 2 plus 1/2 is 4 over 2 plus 1/2, getting a common denominator, which is 5 over 2, so our exponent is 5 over 2. Number 7, log base 3 of -9 is asking the question 3 to what power is -9. This is impossible because we can't have 3 to any power will always be positive, not negative, and so there's no solution. Log base 5 of square root of 25 is asking the question 5 to what power is equal to the square root of 25. The square root of 25 is 25 to the 1/2 power, and 25 is 5 squared, still to the 1/2 power, and we multiply our exponents 2 times 1/2 and get 1, which is 5 to the first power. Now there's an easier way to do this. We knew that the square root of 25 is just 5, so we could have also just taken the square root of 25 and got 5 to the 1. Either way, we get x, our exponent, is equal to 1. Number 9, log base 27 of 3 is asking the question 27 to what power is 3? 27 is 3 to the third power, and 3 is 3 to the first power. Multiply our exponents here, get 3 to the 3x equals 3 to the 1. So our 3x must equal 1. Divide by 3 and you get x is equal to 1 over 3. 10. Log base 9 of 1 is asking the question 9 to what power is 1? Anything to the power of 0 is equal to 1. So this is equal to 9 to the power of 0, so x is 0. Log base 2 of 1/8 is number 11, asking 2 to what power is 1 over 8? 8 is 2 to the third, and 1 over 2 to the third is 2 to the negative third, so our exponent is negative 3. Number 12 is log of 10,000, and it's the common log, and if we have the log without the base is 10. So it's asking 10 to the what power is 10,000. We got 4 zeros there, that's 10 to the fourth power, so our exponent is 4. Number 13, we have another common log asking 10 to what power is 1 over 100. 100 is 10 squared. 1 over 10 squared is 10 to the negative 2, so our exponent is negative 2. 14, we have a natural log. When you have the ln, it means log base e. So it's asking e to what power is e to the fifth power? Well, our exponent here is 5. 15 is also a natural log, asking e to what power is 1 over e to the fourth power. 1 over e to the fourth is e to the negative 4, so x is negative 4. 16, log base 3 of the 8th root of 27 is asking the question 3 to what power is the 8th root of 27? 27 is 3 to the third power, and the 8th root of 3 to the third power is 3 to the 3/8 power. So 3 to the x equals 3 to the 3/8, so x is 3/8. (17 to 19), we're finding which two consecutive integers the logarithm lies in between. And so 17, we're asking the question 3 to what power is 30? Well, we know that 3 to the third power is 27, and 3 to the fourth power is 81, and 30 is between 27 and 81, so our exponent is between 3 and 4. Number 18, 4 to what power is equal to 21? Well, 4 to the second power is 16, and 4 to the third power is 64. 21 is between 16 and 64, so our exponent is between 2 and 3. 19, 5 to what power is equal to 18? Well, 5 to the first power is 5, and 5 to the second power is 25. 18 is between 5 and 25, so our exponent is between 1 and 2. 20 to 22, we have to find the y-intercept if it exists for the following functions. And to find a y-intercept, you plug in 0 for x. So on number 20, if we let x equal 0, we get y is log base 3 of 0 plus 9, which is 9, minus 5. And now we need to evaluate log base 3 of 9. Log base 3 of 9 is asking the question 3 to what power equals 9. And we know that would be an exponent of 2. So back to our problem here, we get y is 2 minus 5, which is negative 3. And that is our y-intercept. Number 21, same thing. I'm going to plug in 0 for x, and I end up with y equals log base 2 of 1 plus 3. I need to evaluate log base 2 of 1. It's asking 2 to what power equals 1. Anything to the power of 0 equals 1, so x is 0. Well, not. Our exponent is 0. So we end up with y equals 0 plus 3, which is 3. And lastly, 22, we got log, common log, remember it's base 10. Plugging in 0 for x into this equation to get our y-intercept, and we get log negative 2 minus 4. So that's asking 10 to what power is negative 2. There's no solution to that because 10 to any power is always positive, and so there's no y-intercept. (23) or to find the average rate of change for this function over a given interval. Average rate of change is a slope, and we're given two values. These are our x values when x is 0 and when x is 15. And so our slope is our y over difference of y, so I'm going to say f of 15 minus f of 0 over 15 minus 0. So f of 15, let's evaluate that. That would be log base 2 of 15 plus 1 minus 5, which is log base 2 of 16 minus 5. So log base 2 of 16, this piece right here is asking 2 to what power is 16? Well, 2 to the 4th power is 16 minus 5, and so we get f of 15 is negative 1, 4 minus 5. So negative 1 minus, find f of 0 now. If I plug in 0, I get log base 2 of 0 plus 1 minus 5. Well, log base 2 of 1 minus 5. Log base 2 of 1 is asking 2 to what power is equal to 1? 2 to the 0 power. And so we get negative 5. Double negative here. And 15 minus 0 is 15. So this is 1 plus negative 1 plus 5 over 15, which is 4 over 15. (24) is similar. This time from 0 to 7, and we're looking for the slope because that's our average rate of change. So f of 7 minus f of 0 over 7 minus 0. So f of 7 is going to be log base 3 of 7 plus 1 minus 5. And that's going to be log base 3 of 8 minus 5. And this one we got an issue here because, well, without using a calculator we have an issue. Finding log base 3 of 8. There 3 to what power equals 8? We can't easily write 8 as a power 3, and so actually let's go ahead and skip 24 because it's a little bit beyond what we've studied so far. Solve for x, number 25. Get a common base. 9 is 3 squared. 1 over 27, that's 1 over 3 cubed. Multiply 2 and the x because they're both exponents, so 3 to the 2x equals 3 to the negative 3 because I get rid of my fraction. So 2x, my exponent, is equal to negative 3. Divide by 2 and you get x is negative 3 halves. 26, 8 is 2 to the 3rd power. Still has the exponent 2 plus x, sorry. And 2 is just 2 to the power of 1. Here I have 2 exponents and of 2, and you're going to multiply those exponents together, so we get 2 to the power, distribute the 3, and you get 6 plus 3x equals 2 to the power of 1. Set your exponents equal to each other. 6 plus 3x equals 1. Subtract 6. 3x equals negative 5. Divide by 3, and x equals negative 5 thirds. Number 27, we are changing 4 to 2 squared. Still got the 1 minus x power, and 8 is 2 to the 3rd. And we're multiplying the 2 and the 1 minus x because those are both exponents of 2. So you get 2 to the 2 minus 2x is equal to 2 to the 3rd. Set your exponents equal to each other and solve by subtracting 2 and dividing by negative 2. And you end up with x is 1 half, negative 1 half. Number 28, 27 is 3 to the 3rd power, still has the exponent 2x minus 1, and 3 is 3 to the 1st power. Multiply the exponents and you get 3 to the 6x minus 3 equals 3 to the 1. Set your exponents equal to each other, add 3 to both sides, and divide by 6. And you get x is 4 over 6, which is 2 over 3. 29, 4 to the 3x plus 5 is 16 is 4 squared to the x plus 1. So 3x plus 5 is equal to 2 times x plus 1. I'm going to distribute. You get 3x plus 5 is 2x plus 2. Subtract 2x from both sides and get x plus 5 is 2. And subtract 5 from both sides to get x is negative 3. Number 30, I'll distribute the negative and you get 3 to the negative x minus 5 is equal to 9 is 3 squared to the 4x. So negative x minus 5 is equal to 2 times 4x, which is 8x. Add x to both sides. Divide by 9, and you get x is negative 5 over 9. (31) 25 is 5 squared to the 2x is 5 to the x plus 6. Multiply those exponents, you get 4x equals x plus 6. Subtract x from both sides. Divide by 3, and you get x is 2. The 32. 36 is 6 squared. And so x plus 1 is equal to, multiply the 2 times x minus 1. And then I'm going to subtract x from both sides and add 2. So x is 3. Number 33, I'm going to change it out of log form into exponential form. So 5 to the power of 0 is equal to 2x minus 7. 5 to the power of 0 is 1. Add 7 to both sides, divide by 2, and you get x is 4. 34, pi to the power of 3 is equal to x. That's just changing it out of log form into exponential form. 35, we get 64 to the power of x is 32. 64 is 2 to the 6th power. 32 is 2 to the 5th power. So 6 times x is equal to 5. Divide by 6 and you get x is 5 over 6. 36, 8 to the 2/3 power is equal to x. And 8 to the 2/3, that means the cube root of 8 squared. The cube root of 8 is 2, and 2 squared is 4, so x is 4. Number 37, we have an equation, and this is just your basic log function, and so it has a vertical asymptote right down the x-axis, sorry, the y-axis, and the equation of that is x equals 0. Also, we can find the x-intercept by plugging in 0 for y and solving for x. So 4 to the power of 0 is x, so our x-intercept is at 1. I'll put a point there. And this is a positive log function, so it's increasing. So that's what our graph looks like. We can notice in our graph it's never going to touch the y-axis, so it's not going to have a y-intercept. The domain, just reading the graph, is from 0 to infinity. Use parentheses only. And the range is from negative infinity to infinity. In 38, we have a translation, and we're moving to the left 1 and up 3. And so this really has an effect on our vertical asymptote. If we're moving left 1, the vertical asymptote is now going to be at x equals negative 1. For the x-intercept, I'm going to plug in 0 for y. And then, oops, that should be a plus 3. Subtract 3 from both sides. And then when you change it out of log form, you get 2 to the negative 3 power equals x plus 1. 2 to the negative 3 means 1 over 2 to the 3rd, which is 1/8. And now I'm going to subtract 1. So x is 1/8 minus 1, which is 1/8 minus 8 over 8, which is 7/8. So 7/8 is between 0 and 1. I'm sorry, this should be negative 7/8. Between 0 and negative 1. About right there, closer to negative 1. For my y-intercept, I'm going to plug in 0 for x, and I get y is log base 2 of 0 plus 1 plus 3. And I want to first find out what the log is. So 2 to what power is equal to 1. So we know that power is going to be 0, so this is 0, so we get y is 0 plus 3, and so that's our y-intercept, 3. So I'll put a point at 3, and so we have this shape here. Domain is from -1 to infinity. Range is from -infinity to infinity. All parentheses. 39, we're describing the translation from f to g. F is the basic log function, base 3. G, we have some translations, so we're going to the right 2, we're going up 5. So translate right 2 and up 5 units. Same idea with number 40, going from the basic log function to a translation. Here we're translating left 1 unit and down 9 units. And there we go for our review.